Hello. In today's video, we are going to take a look at graphing linear inequalities in two variables. So, starting right off in our lesson, when two expressions have the same value, they can be joined by an equal sign. If two expressions do not have the same value, they can be joined by one of the inequality symbols shown below. So, I know we have all worked with less than or greater than, or less than or equal to, or greater than or equal to. So what we're doing today is we're making them into linear equations with inequalities in them. So a lot of our equations that we're working with today, they're either going to be in slope-intercept form, or we'll want them to be in slope-intercept form. And then at the end of the video, I'll show you guys how to use a calculator in order to solve these as well. So we have a linear inequality in two variables relates to variables, often x and y, with an inequality sign. The solution, xy, makes the inequality true when the values of x and y are substituted into the inequality. So again, if we substitute two numbers into our equation, and that comes up with a true statement in relation to our inequality, then that will be in our solution set. So I'll give you guys a couple examples on what that will look like. The first one being if we have y is greater than negative 3x plus 5, and we plug in the point 2,9. Now, we could pick any ordered pair ever, and we just have to determine if it's true or not. So you can see they plugged in that 2 for x and that 9 for y, and then they just started simplifying this equation. So we have 9 is greater than negative 3 times 2 plus 5. That comes down to 9 is greater than negative 6 plus 5, and that 9 is greater than negative 1 in the end. So because this is a true statement, that 0.29 is in our solution set. So I'll show you guys what this looks like on a graph in a little bit, but we're just going to check a couple more ordered pairs with some linear inequalities. So for this one, even though our equation isn't in slope-intercept form, we can still check ordered pairs to see if it comes up with a true statement. So we have negative 3 and negative 7, so I'm going to plug those in. 3 times negative 7 minus negative 3 is less than negative 18. So we get negative 21, and that subtracting a negative turns into a plus. So that's plus 3 is less than, that's negative 18. Negative 21 plus 3 is negative 18. And this statement is false. Negative 18 is not less than itself. If it were less than or equal to, then that would be true. However, since we don't have that bar underneath to add in that stipulation of equal to, this one would not work out for us. So the statement would be false. Okay, moving on. Again, it's not perfectly in slope-intercept form, but we are still able to plug in a point to see if this would be true or not for that point. So we can say negative 2 times 4 plugged in for y is less than or equal to 1 minus negative 3. Again, we're subtracting a negative, so that turns it to a plus. Negative 2 times 4 gives me negative 8 is less than or equal to a positive 4. Now that would be true. Because that is true, that means that negative 3 comma 4, or that ordered pair negative 3, 4, is in our solution set. All right, so jumping into graphing these linear inequalities. So our first step is to get our equation in slope-intercept form. So as you just saw a lot of examples of, we can figure out if a point is in the solution set without having the equation in slope-intercept form. However, if we're going to graph, it's a lot easier to graph things in slope-intercept form. Second of all, when we're graphing inequalities, we have some different stipulations based on the symbol that they give us. Now, if we have less than or greater than, you can see we have this dotted line. And if we have less than or equal to or greater than or equal to, then we use a solid line. Okay, so we will always have to check for that. It's probably one of the first things we look at when we're dealing with these kinds of problems. The next thing, and this is just kind of a tip, if the point 0, 0, or our origin point is not on our line, that's probably the easiest point that we could ever pick. So if we can pick 0, 0 and plug those values in and determine if that's going to give us a true statement or not. If it is true, or if any point that we pick gives us a true statement, that's the side of our equation that we would shade in. So when we're graphing linear inequalities, we shade in the side that gives us true statements, because any point on that side of the line will give us a true statement. If it's false, then we shade in the opposite side. So I'll show you guys what we mean by this. So in this example, we already have a line graphed, and you can see that that is a greater than or equal to symbol. So because it's greater than or equal to, you can see they have a solid line. Now, we just have to plug in an ordered pair, so we can pick any point that we want. I'm going to pick 0, 0, because like I said, in my opinion, that's the easiest thing that we could possibly pick. So 3 times 0 plus 0 is greater than or equal to -9. Simplify that, and we get 0 is greater than or equal to -9. Now, that is a true statement. Because our point at 0, 0 is right here, that means that that entire side of our equation gives me true statements. So we would shade in that upper half of our equation, and all of those shaded points are answers that I could have. Now moving on. If I gave you an example where we had less than, so you can see we have graph 5y plus x is less than 20. We want to change it to slope-intercept form, so you can see they went through the work and did that here. Now, because that is just a less than symbol, we have a dotted line. And again, I would plug in 0, 0 in this situation, and we would have 0 is less than 4 in the end. Now, again, since that's true, I would then shade that side that has 0, 0 on it. All right, let's try this last one out. Let's get it in slope-intercept form. We can test everything out that we just talked about. We have -2y plus 10x is less than -2. So the first step we're going to have to do, 10x, is we're going to have to subtract that 10x from both sides. Because I want it in slope-intercept form, I'm going to kind of squeeze that in between my inequality and that -2. So we will have -2y is less than -10x minus 2. Last step to get it in slope-intercept form, divide by -2, divide this by -2, and divide that last term by -2. These cancel out. Remember, because I'm dividing by a negative with inequalities, this rule still holds true, where I'm going to have to switch that sign around. So this should be greater than now and not less than. -10 divided by -2 gives me 5x. -2 divided by -2 gives me +1. I'm going to graph this line. So we start at this +1, And I'm going to go 1, 2, 3, 4, up 5 over 1. I'm going to go down 5 to the left 1. I'm going to do my best to get us a dotted line in there. All right, now, since I'm a little bit close to 0, 0, I'm not gonna mess with it in this problem. Another easy thing that you can do is you can pick any point that's on one of our axes. So let's say I want to pick this point way up here at 10, 0, 10. If I'm dealing with 0, it makes things easier because 0 is going to cancel out numbers, or it's just easy to compare other numbers to. So I have 10 as my y value is greater than 5 times 0 is 0 plus 1. All right, so I can tell on this graph that my point is on the left side of my line. So that means everything on this side, except for the line because it's dotted, is an answer. Now, if that was a solid line, the line also would give me answers because we can be equal to. That's the difference when we're graphing inequalities. So because this is a dotted line, points that are on my line do not count as answers. However, everything to the left or to the right, depending on the problem, does count. All right, now I'm going to try something a little different here. I'm going to try to show you guys how to do this on a calculator. So I have my y equals menu. You just hit that y equals button. And I just want to graph y is less than 4. So I have 4. Now I can hit enter and that can give me a flat line over at 4. But if I want an inequality, I have this over to the left. I just moved my arrow over to the left. I'm going to hit enter. Now on the computer it changes this. You just keep hitting enter on your calculator. So if I have that triangle, you have these two different options. This one here means greater than. This one means less than. So if I hit enter on that, we'll say okay. I should have a line at 4 and everything underneath it should be shaded. There's my flat line at 4. You can see everything underneath that line is shaded now. I'm going to do one more example. You can see we have 3x minus y is less than or equal to 2. Let's simplify that. Minus 3x minus 3x. Divide by a negative. So that turns to greater than 3x minus 2. So I'm going to graph this equation. Now we have greater than, so I'm going to choose that other option that we had on our calculator. The one thing for you to keep in mind is if that is going to be a dotted line or a solid line to determine if different points can be included. So let's see. Go back to my y equals menu. So that was y is less than 4, less than or equal to. Now here we have 3x plus minus, minus 2, enter. Now I don't want just the line, I want that to be greater than. So this is the symbol that we use. You can see it bigger over here for greater than. Hit OK. Now if I graph that, you can see everything there is greater than. Now, even further, let's say I had a system of inequalities. Everything in the double shaded region would be my answers for both of these. But just for that red line, everything to the left-hand side is greater than or would be a true point for this scenario. All right, that is everything that I have for you guys. Here are your homework problems. If you didn't get them in the lesson, I hope you have a great day.